In an automotive landscape increasingly defined by efficiency, electrification, and the relentless pursuit of sustainability, there exists a singular engine that stands as a defiant, monumental testament to unbridled power and pure engineering audacity. We are, of course, referring to the Bugatti W16. It's an engine that doesn't merely represent a pinnacle of internal combustion. It might well be its grand, majestic, and perhaps final act on the global stage, a swan song for an era of excess. Our journey into this mechanical marvel begins not on a racetrack, but in the late 1990s within the strategic mind of Ferdinand Piëch. As the visionary chairman of the Volkswagen Group, Piëch orchestrated the acquisition of the dormant yet legendary Bugatti marque, a brand synonymous with pre-war elegance and performance. His mandate was both breathtakingly simple and extraordinarily ambitious: to conceive and construct the fastest, most luxurious, and unequivocally most technically advanced road car the world had ever witnessed. This wasn't merely about setting new benchmarks or achieving incremental improvements. It was about shattering existing paradigms, pushing the very boundaries of what was considered mechanically possible in an automobile. A declaration that Bugatti, under new stewardship, would once again redefine automotive excellence and engineering prowess. Piëch's monumental vision, demanding unprecedented levels of power and refinement, meant conventional engine architectures simply wouldn't suffice. Established V configurations, even a theoretical V16, presented inherent packaging and length challenges that would compromise the vehicle's dynamic goals. The engineering team, tasked with this seemingly impossible brief, turned to a radical solution: the W formation. This wasn't merely a larger engine, it was a mechanical marvel, a complex piece of horology in metal, unlike any production engine seen before. Instead of a traditional, prohibitively long V16, the Bugatti W16 is, in essence, a masterstroke of packaging. It ingeniously integrates two narrow-angle V8 engines, each with its own cylinder bank, joined at a single common crankshaft. This compact, immensely powerful arrangement, displacing a colossal 8.0 liters across its 16 cylinders, provided the robust foundation for the targeted, then unthinkable, power output. To propel this engine beyond mere potency into the realm of hypercar legend, it was then meticulously augmented with 4 turbochargers. These forced induction units were a crucial component, enabling the W16 to compress enough air to reach and ultimately exceed the initial audacious target of over 1,000 metric horsepower for the nascent Veyron project. Forging an engine of such colossal power, however, represented only half the engineering equation. The more profound and perhaps more relentless conflict lay in effectively managing the sheer explosive output this extraordinary W16 could unleash. Generating over 1,000 horsepower is not merely a matter of efficient combustion. It's a thermodynamic crucible, demanding an utterly unprecedented cooling architecture. The immense energy conversion within those 16 cylinders manifests as an astronomical heat load, necessitating a system of radiators and intercoolers far beyond anything previously conceived for a road-legal automobile. To prevent a catastrophic thermal runaway, the nascent Veyron project ultimately integrated a staggering 10 individual heat exchangers, a complex, interconnected network dedicated solely to dissipating the engine's inferno and maintaining optimal operating temperatures under the most punishing conditions. Beyond thermal regulation, the prodigious thirst of this Leviathan engine presented another monumental hurdle. Fuel delivery required a sophisticated, multi-stage high-pressure system capable of supplying vast quantities of precisely metered gasoline under extreme and fluctuating loads. A continuous deluge, not merely a trickle, into the combustion chambers. Furthermore, ensuring the long-term reliability of such an intricately complex powertrain, while simultaneously developing the intricate active aerodynamics and immensely powerful braking systems required to safely harness its stratospheric speed, represented a comprehensive engineering campaign. This was a holistic war against the fundamental laws of physics, meticulously waged across every single component, from the smallest sensor to the largest carbon ceramic disc. The sheer magnitude of the engineering hurdles the Veyron presented naturally bred a deep-seated apprehension within the automotive world. Many observers, both within rival manufacturers and among seasoned critics, openly questioned the viability of such an ambitious undertaking. Could a vehicle with a 16-cylinder engine generating this much power truly be constructed with any semblance of reliability, let alone offered for sale to discerning clientele? The very notion of consistently exceeding 400 kilometers per hour in a production car seemed, to most, an impossibility, a quixotic quest that would inevitably crumble under its own weight and complexity. Yet, when the Bugatti Veyron finally emerged from years of intense development, it didn't just meet expectations, it utterly obliterated them. This wasn't merely another fast car, it was a paradigm shift. The Veyron became the first series production automobile to reliably achieve and surpass the elusive 400 kilometers per hour barrier, a feat that had long been confined to the realm of concept cars and land speed record attempts. Its arrival wasn't just a debut, it was a declaration. The industry, initially steeped in doubt, was compelled to acknowledge a new, formidable standard. Competitors found themselves scrambling to recalibrate their own benchmarks, their previous definitions of hypercar instantly rendered obsolete. The W16 engine, once viewed as an extravagant folly, solidified its status not just as an engineering marvel, but as an undeniable symbol of what could be achieved when relentless ambition was paired with an almost limitless dedication to pushing the boundaries of automotive science. What happened next changed the industry. The W16 engine's remarkable saga, having set unprecedented benchmarks with the Veyron, did not conclude there. Instead, it embarked on an even more demanding second act, finding its new, profoundly potent home within the Bugatti Chiron. For this successor, the formidable W16 underwent a comprehensive and meticulous refinement process, pushing its already astonishing output from 1,000 horsepower to an almost unbelievable 1,500. This monumental leap in performance wasn't a mere incremental adjustment. It necessitated a complete re-engineering of critical components. Engineers integrated significantly larger turbochargers, not just for more boost, but to manage a broader, more accessible power band, alongside a thoroughly revised fuel injection system designed for enhanced precision and efficiency under extreme loads. Further advancements in cooling architecture, including a complex array of intercoolers and radiators, and the deployment of cutting-edge materials in the engine block and internals, were absolutely essential to manage the immense thermal and mechanical stresses generated by such unprecedented power levels. The Chiron, armed with this evolved W16, did not merely follow in the Veyron's footsteps, it carved its own, even deeper mark in automotive history. It continued Bugatti's tradition of shattering records, most famously becoming the first production automobile to conclusively exceed the 300 miles per hour barrier. This wasn't just a number, it represented a new zenith of automotive engineering, a sustained velocity that few, if any, thought attainable in a street-legal machine. Its sustained dominance on the global stage served as an undeniable testament to the W16's inherent design flexibility and the unwavering dedication of its engineers to relentlessly push the performance envelope, even as the broader automotive landscape began its inevitable, profound pivot towards electrification. The Chiron proved the W16 was not a static achievement, but a dynamic platform capable of continuous, breathtaking evolution. Despite this testament to its enduring adaptability and the sheer will of its creators to push boundaries, even the mighty W16 could not, in the long run, escape the relentless march of progress and the evolving imperatives of global regulation. Just recently, Bugatti made an announcement that, while anticipated by astute industry observers, still resonated with a profound gravity. The W16 engine, the very heart of these hypercars, is being phased out. This pivotal decision is not a reflection of the W16's inherent capabilities or its engineering brilliance. Rather, it represents a strategic pivot towards the future, aligning irrevocably with the broader automotive industry's accelerating trajectory towards hybrid and fully electric powertrains. This moment signals the definitive close of an extraordinary epoch in automotive history. The W16 stands as arguably the last major production engine of its kind, a pure internal combustion behemoth, conceived and refined without the aid of electrification. It is the ultimate expression, a final boss, if you will, in the multi-decade evolution of the petrol engine, a machine crafted for raw, unadulterated power delivered solely through the combustion of fossil fuels. Its retirement is far more than a mere model change for Bugatti. It is a poignant, symbolic moment for high-performance vehicles across the entire automotive landscape. It marks a profound turning point, fundamentally altering how we define speed, luxury, and the very essence of automotive power moving forward. The W16's sunset is indeed the sunset of a titan, concluding a magnificent, fuel-driven chapter. While its roar may soon fade from production lines, the Bugatti W16 was always far more than just a colossal power plant. It stood as a grand, audacious experiment in pushing the absolute limits of mechanical engineering itself. Its relentless development spurred profound advancements in critical areas, from the intricate dance of thermal management under extreme loads to the pioneering use of advanced materials, science capable of withstanding unprecedented stresses, and the precision required for high-pressure fuel systems delivering immense energy. These aren't just hypercar-specific lessons. Their underlying principles subtly influence even more conventional automotive design, nudging the entire industry forward in unexpected ways. The very existence of an engine like the W16, even if its direct application remains limited to a handful of ultra-exclusive hypercars, serves a vital purpose. It challenges engineers across the spectrum to think beyond current constraints, to question what's truly possible, and to redefine the boundaries of what a combustion engine can achieve. Moreover, its eventual departure sparks a philosophical debate that resonates deeply within the automotive community. The enduring place of unbridled mechanical passion versus the increasing, undeniable demands for efficiency and environmental responsibility. It forces a contemplation of what we truly value in an automobile. Ultimately, the W16 stands as a powerful, tangible reminder of what human ingenuity can achieve when tasked with creating the ultimate mechanical expression, regardless of the immediate practicality or the shifting tides of regulation. It is a monument to an era, a testament to relentless innovation. As the curtain gracefully descends on a remarkable era, the Bugatti W16 engine will forever be etched into the annals of automotive history. Its significance, we find, transcends mere colossal horsepower, embodying instead a profound, almost defiant audacity in its very conception. This wasn't simply another powertrain, it was unequivocally a mechanical swan song, a final thunderous declaration from a period defined by the uncompromised internal combustion engine and the relentless pursuit of its ultimate expression. Its very existence wasn't the result of a casual design exercise. Rather, it was painstakingly wrestled into being, a bold challenge flung against the prevailing currents of technological change and evolving regulations. Such an engine, with its complex symphony of cylinders and turbos, serves as a potent, tangible reminder of what human ingenuity can achieve when pushed to its absolute limits. Here, within the Vintage Motors vault, we continually unearth these hidden narratives, the engineering marvels, and the grand, sometimes quixotic ambitions that have meticulously shaped the very vehicles we navigate today. Each intricate story, much like that of the W16, offers a deeper understanding of automotive evolution, underscoring the relentless human drive to innovate, to push boundaries, and to create machines that resonate far beyond their functional purpose, even in the face of impending paradigm shifts. It's a legacy of passion, power, and the profound art of mechanical design.